Okay, so in order for you to understand how to do cloud security, I'm going to just give you an overview of all of the pieces in Google Cloud that allow you, the tools that Google Cloud provides you to secure your cloud resources. And this will then allow you to do the CTF that's all on Google Cloud, which will be the assignment for this week. And so again, we have been talking mostly about security within an application, but we want to talk about how do you protect your resources after the adversary has compromised your application. And to give you an overview of the kinds of things that you need to protect, if you go down the AWS path, they have this figure that they show you almost immediately when you do your training. That's this shared responsibility model for their security. And so I'm only going to give you the top half of the responsibility model because there's like a bottom half that AWS is responsible for. This is the top half. This is like AWS is forcing you to take care of all of this. And this is the stuff that you as a sort of a business and a provider, you have to do. Like this is stuff that AWS can't help you with, like client-side data encryption. Like if you're storing your stuff and you're not encrypting it, they can't do anything about that. It's in the clear. Like you put that thing up in a storage bucket unencrypted in public, nothing I can do. Server side and then network traffic, like if you're configuring your website with HTTP instead of HTTPS, AWS can't do anything about it. The ones that we're going to look at for this particular section of the course are these middle two ones. We're going to talk about the platform security. And what this means is all of the cloud resources. And the cloud resources are managed by this thing called IAM, Identity and Access Management. And we're also going to talk about how you do this layer. And this is for the legacy stuff. So the server-based stuff requires you to configure operating systems, networks, and firewalls. So those are the two parts of this. We're going to split this up into what I call legacy security in the cloud. And this is your traditional server-based security. The other term you'll hear for this is lift and shift, where you're taking your legacy app, you're lifting it, and you're shifting it to the cloud, like as a entire piece. You're replicating the network topology, the server, the software stack, just taking it out of your data center and putting it into the cloud provider's data center. So that's what legacy cloud is. You can retain your Unix and Windows accounts, the permissions, the SSH keys, the firewall rules. You want to replicate all of that stuff in the cloud. You might have a database server that you want to host in the cloud. You want to basically copy over the username password configuration for that database server. So that's legacy security. It looks a lot like IT security of today. And then the other aspect is cloud platform security, and that's done access to cloud resources after you have done your sort of deployment into the cloud. So basically access to resources by developers, the operations team, any organization or any entity in your organization. Okay, and that's done with IAM. So again, I'm going to run through just the concepts that you need to understand the exercise. And for those of you who took the cloud class and did these exercises last quarter, I'm going to ask you to do them again. But hopefully, the things you're going to do are going to make a lot more sense because you didn't have this in front of it. Okay, so I'm going to talk about legacy security in the cloud first. So the idea here is you're running your regular individual servers and your software that you've configured explicitly. So it's either Linux or Windows. And then typically you will have your traditional way of authenticating to your machines. And that's done using things like SSH, VNC, or RDP. So virtual network connection or remote desktop protocol is for Windows is RDP. So for SSH, the way Google implements SSH is through SSH keys. Okay? You could implement username and password, but the preferred way of doing it on Google is through SSH keys using their console. And the way this works is that you typically supply an SSH key upon configuring a virtual machine. And this is similar to what you would what you did with GitLab. If you wanted to streamline your access to GitLab, you would associate an SSH key to your account so that you can just do SSH access. The same thing is happening here. And what happens is the key gets stored in what's called metadata. So we talked about the metadata server. One of the things that goes onto that metadata server, SSH keys that give people access to that server. So the metadata server stores that key. And as soon as you create this key in the metadata, when someone SSHs with this account key, with the private key associated with this public key, then the user that is associated with that SSH key is automatically created on that virtual machine. So a user account with this username is then created when you SSH into the VM. Okay. You can also, if this is a key that has this name, you can also say, I want to manually SSH into there with that IP address on the client. So this is what the client would do to access that virtual machine. When you go to the web UI and you click that nice SSH button on the web console, all of this stuff, creating an SSH key and doing this, that's all done dynamically. It's one-click setup of the SSH key, the generation of the key, adding it to the metadata, and then doing this is all done for you. So that's the beauty of that one button that you use to SSH into a VM that you create on Compute Engine. And of course, the VM that I have put up there, WFP, doesn't have that. You need some special software installed to do that, and I don't have that on that VM. So that's why if you SSH'd into that virtual machine, you're using old school authentication on that. That's not the way Google wants you to do it. But Ubuntu 12.04 doesn't run Google's auth package. So that's what I'm doing. In case you're curious on how that got implemented.
Oh, we on like 19?
Yeah, we're on 18, but yeah, actually, if you're interested, I can give you the 1204 server. Okay, so the next thing is legacy SQL databases. And so when you go into CloudSQL, you can say, hey, you know what? I want a VM that has this name and then has a default user password. For the user Postgres, it has a default password or a password that is specified. And this basically sets you up a pre-configured Postgres SQL server, and it'll give you an IP address. So it's actually bound to a virtual machine. And then you can do this. This is traditional Postgres access to that database, where you give it a user, a password, and an IP address, and that's the Postgres port, and then you have a name. So this is for legacy operation. The last thing is firewall rules. So the idea of firewalls is to filter the traffic going to your server, and you would, it's basically modeled off of Linux IP tables. So IP tables is the Linux firewall that is pre-installed on all Linux distributions. So if you wanted to do some port filtering, you could do it with that package. The firewall rules here are basically the equivalent, but what you are allowed to do is, the idea is that the cloud project can define the rules, and then you can decide which virtual machines to apply those rules to, rather than SSHing into each one of these virtual machines and applying the rules. So the cloud is giving you a way of pushing those rules out there at the higher level rather than doing the manual setting. Okay? And then the access control is based on a certain number of attributes. Do you want to filter the incoming traffic to that machine? Do you want to filter the outgoing traffic from that machine? Do you want to filter certain address ranges, sources and destinations? Which ports do you want to allow? What services do you want to export? Okay, so this is what it looks like on Google Cloud. You have a bunch of machines here, and then there are a bunch of firewall rules that get applied before traffic from the internet is then allowed to all of those instances. And so here, you're basically applying these rules before they hit your machine, rather than having an IP. So if you had installed IP tables rules here, the traffic would actually get to your instance before you dropped it. So the idea here is to drop it at the edge. And so you're specifying the rules, Google is implementing it towards the edge of the internet, and then it's dropping there. You have a question, yeah?
Yeah, with the arrows pointed that way, is that ingress?
That's ingress. Yeah, so this direction is ingress. I have an egress filter on Web for Pentester because when people compromise Web for Pentester, the attack that they do is a brute force SSH attack, scanning for default username and passwords on SSH servers. So I do an egress filter that says deny all outgoing SSH. And so that is the one case where I've used an egress filter. But most of this stuff is ingress. And of course, if you've done the Web for Pentester filtering one, that's basically what PDX80 is. So because that VM is vulnerable, I don't want any access to be allowed to port 80 because it's got that command execution vulnerability that allows anybody to execute anything they want to on that machine. And so this is what you did if you went back and did the filtered version of this thing, or the no-filter version. This is done using network target tags. So you create a label, and that label is this target tag, which is right there. And then you say, hey, how do I want to define the filter? And so this one says, you know what, source filter, and get all the IP addresses in this range. So these are the port and state IP addresses. And allow specific protocols and ports to that, to port 80 using this filter. So this is a source filter on port 80, going to whatever machine it's protecting. And then when you instantiate your virtual machine, you say, hey, I want to apply this tag, this filter tag, to that virtual machine, and this restricts access to anybody other than Portland State users onto port 80. Okay, so that's just an example of the firewall rules. And we'll go through, so this is all Google Cloud. Next week we'll do all the AWS equivalents of all of these things, which is a little different. It's similar but different. One thing that Google Cloud does is it allows you to do predefined target tags. So in this case, if you go into the firewall rules of VPC network, you'll see these are the default targets that have been already defined for you. And so if you click the allow HTTP traffic, it actually applies this tag to your virtual machine. It's actually doing this using the target tag mechanism. Okay, so that's traditionally how you would do a filter in the cloud. Other questions about what that does? Okay, so the other part, and the more complicated part, is IAM. And I don't know if I'm going to get through this with 10 minutes. I mean, I don't think I want to start it if I can't finish it. Yeah, I'm not going to finish that. So I am going to wait. I'm going to wait till next class. So if you are adventurous and you want to start, let me talk about what I want you to do this week. Okay, so we last left off talking about the different ways of doing security in the cloud. And I got through, there are two ways. There's legacy security in the cloud. How do we deal with firewalls and SSH logins? When you actually have servers you're setting up, you're going to secure those servers using the old school methods. We're going to today talk about how do you manage access to cloud resources. This is a completely separate way of doing security. So you're almost like doubling the amount of security knowledge you need to know when you move to the cloud. And this is why I just read an article today. There's a lot of companies that this is like their #1 reason not to move to the cloud. Because you need to hire like a super specialized, very expensive engineer, security engineer, in order to do it right. And there aren't a lot of those folks out there. So this is going to get you started, but by no means is this going to be comprehensive. My goal is to just give you an idea of how it works, enough to get you some good practice when you do the CTF. So that's the idea. When we talk about cloud platform security and sort of native security in the cloud, this is typically done through something called IAM. IAM stands for Identity and Access Management. So identity being authentication, access management being the authorization. So we already talked a little bit about this when it came to web security. This is the same ideas pointing to cloud resources and cloud accounts. So this is named, fortunately, the same on Google and AWS. You go to the same place, there's the same IAM thing, and it basically means the exact same thing. There's some differences between the two, how the two implement IAM. And these are things, this is why I want you to do all the Google stuff this week. Be done with the Google CTF so that we can just shift over to the AWS stuff next week. You do not want to be switching back and forth between the two. I've tried and it gives me a headache. So yeah, just finish the Google stuff this week if you can, and then transition over. Okay, so just to recap, with identity, we mean authentication. And this is validating that the identity of the users and potentially the applications that are needing to access your cloud resources. So with users, just as before, just copied straight from the web security stuff. What you know, what you have, who you are, where you are. And in fact, some of the cloud platforms, they're just going to use your authentication from the web stuff. And we'll talk about that. For applications, this is typically what you have to access services, right? Because, what you have or what you know, because it's embodied in what you have. And that's typically keys. So API keys, we'll talk about service account keys. Any kind of access key is what you're going to do for authenticating applications. In legacy deployments, this will also be where you are. So we didn't talk a lot about virtual private cloud, but these are ways of partitioning your network so that you can partition the private stuff into a private set of IP ranges and the public stuff in a different set of IP ranges. I skipped that because none of the levels in either the AWS stuff or the Google Cloud stuff requires you to set up or break into VPCs. It's just there, so I'm going to leave it at that. You'll come across it. If you do further training in AWS or Google Cloud, you will need to know how to create private subnets, how to set up the rules and networking in those subnets in order to actually get your project to be secure. But I'm going to skip all of that. Okay. So the other part of IAM is access management. And with access management, this basically describes policies that you attach to users that do two things. They specify which actions can be done on which resources. And then you take this policy, the policy is the right two boxes, and you attach them typically to a user or a principal. So that's what we're doing for access management. There are different kinds of access management policies. There is the kind that you're probably used to if you run Linux or you're logging into the Linux lab machines. This is called discretionary access control, where the owner of the object can decide on who is allowed access to that particular object that they own. And it's usually user, group, or other. So that's what we're familiar with. There's also the governmental access control. So if you imagine top secret, all the different levels of top secret classified information, these are things that are considered mandatory access controls where it's not the owner of the object that gets to decide, it's the governing agency, whoever is implementing the security control that gets to decide who has access to what, okay? And so this is mandated in high security environments. So if you work for the government, eventually you'll come across something like this. The other one is role-based access control. And the system does decide in this case, but it's decide on user roles that are assigned to particular individuals or groups. And so this role has policies that can be attached to it, just like in that previous slide that I mentioned. And then these policies specify what privileges are allowed in that policy. And you would usually attach the policy to the role. So if you have an IT admin person, then they would get particular, for example, network access to your cloud project. If you had a software developer, maybe they get App Engine or Lambda access to your project, but then they don't get to touch the billing account, right? So and so you have you're the owner of your own Google Cloud project, so you can set the billing, you can mess around with the network, you can do App Engine, Cloud Functions, you got everything. But if you have a large cloud project, you're going to need to partition off the roles, and that's done using this methodology. Okay. When you have something like this, it's really important to apply the principle of least privilege. We didn't really talk about this much in web security because usually when you log in, you should only have access to your own stuff. So there's no need for a role when it comes to web security. But in this case, because you have project resources and they're shared amongst different employees, for example, you need to be able to have a policy, a way of mapping the policies to the roles that provide you a minimal set of privileges for that person. Okay? So the minimal level of access so that they can do their tasks. Okay, so both AWS and Google Cloud employ role-based access control, and it's done in two forms. The main form, and the only form that's in your exercises, is this one, identity-based access, because that's the typical way access control is done. So let's talk about identity-based policies. The policy is going to determine what action can be done to what resource, and then they are attached to identities. So that's what we're going to talk about. So what actions? Reading, writing, deleting, creating. Those are the actions to choose from, and then the resource that they're specified on: virtual machines, database instances, storage buckets, network subnets, these sorts of things. Okay, and they are attached to these identities, or they're attached to the role, and then the role is attached to the identity. And it's actually better that you attach it to a role, because you want that policy to be embodied in a role so that you just add users based on what their role is. So this level of indirection is recommended best practice. When you go into the AWS stuff next week, you'll see that they recommend not attaching a policy directly to a user, because then you're individually managing users. They want you, so if you have the IT admin role attached to 10 of your admins, and then all of a sudden you want to add a permission to your IT admin staff, then you have to go and add it to 10 people. So the idea here is that you have an IT admin role, they have a new permission, you attach it to that role, and everybody gets it, right? It's a level of indirection. So but the cloud allows you to attach a policy directly to an identity. In terms of the identities, it could be an email address, it could be an IAM user account, a group, a service account, any of these identities that we'll talk about per platform, actually. The notion of identity changes between the two platforms. They have two different models. Okay. In terms of roles, when you attach these things to roles, there are roles that you can create yourself. These are custom to you. So if you have a specific set of permissions that you want to assign particular roles and groups, you can actually define your own. That's very common. There are also these predefined roles with sets of permissions for your convenience. Because with 3,000 permissions there, yeah, you're not going to go and say, yep, needs that one, doesn't need that one, needs that one, doesn't need. You're not going to do that. So there are pre-canned roles. And these defaults are a point of contention because, you might not need every single permission in that curated role, and then you would have to remove it. And so sometimes Google will go and say, the compute engine default role has too many permissions, like full access to the storage buckets, and they'll remove that permission and break a bunch of projects that assumed. So these things will happen in fact, that happened last year, where all of a sudden a code lab that used to work stopped working because they pulled that default permission off of a role that you needed. Okay, so some of the common ones on Google Cloud, at least, the owner of the project owner role has everything, all 3,000. The editor role, the reader. I think the editor is everything except billing. Is the editor, and changing the owner is what the editor has. The reader, read-only. You can see all the resources, but you can't change anything. And then the billing administrator is just handling the billing account. Okay. I am going to skip resource-based policies, but I just want to mention that these things do exist, and they typically exist when you want to attach permissions directly to objects. So I talked about roles attached to, or policies attached to roles. You could actually attach on a policy to the resource. You say, hey, everyone gets access to this index.html file. So that is also there, but that's typically for storage buckets, and we're going to skip this. But I want you to I want you to know that we skipped it in this class. Okay, so I am going to talk specifically about how all of that stuff gets implemented in Google Cloud. And so this is through Google Cloud Platform's IAM, and so you see the person symbol in the shield. That is their icon. Hopefully I don't change it. Otherwise I have to update my slides again. You're always having to update the slides. New marketing, new UI, so and it just comes with the territory. I'm going to talk about IAM by showing you what's in my IAM. So here is my the CS495 web security project. So this is the project that you get that WFP1 and WFP2 ISO image from, or the machine image from. It's hosted on my project here. But what I have done is I have allowed access to anybody in Portland State pdx.edu to have read access to that instance so that they can launch virtual machines. And I'm going to show you the mechanism that we do this with. So if I go to this project, I click on IAM. At the top of this IAM, you'll see I have members and roles. I'm interested in the members, and you'll say the member name and then the role that is attached to them. For Google, identity is one of these four things. Okay? It's a Google account, a service account, which I'll talk about later, a Google group that you can create yourself in groups.google.com, or a Google Apps domain. So in this case, we are, oh, I hate you. This happens all the time when I talk about you, Google. You know, Google, sometimes it's not about you. All right. Hopefully that works. Sorry. I'm going to stick you back there, Google. I am talking about you, kind of, sort of. Okay, where was I? So Google account, service account, Google group, or an apps domain. So Portland State is a G Suite organization. So we do have, this is how I ACLed your compute instance. It's like anybody that has the pdx.edu domain, and then when you authenticate with pdx.edu, you're part of this domain, and anyone else that's part of this domain that visits this thing can get WFP1 and WFP2. Okay, so the first one is a Google account. And so one of the really cool things about Google Cloud is that it uses standard OAuth for identity. Like, you don't have to create separate identities for users, right? Like, they can use the regular pdx.edu account. Like, for your projects, if I wanted to give one of you write access to one of my resources, I don't have to create an account. I just fill in your email address and say, yeah, editor. So and you'll see it's different in AWS land, but in Google's just using standard OAuth to pull this off, to do the identity. And then the people running the Google authentication thing, they're in charge of identity. And they'll just vouch for the fact that you knew your username and password and are going to access this using that authentication information. Okay. The other thing that you can identify as is a service account. And service accounts are typically used for any software or application that you have on your project. Say you have a compute engine running a web server, say the Web for Pen Tester thing, and you wanted that web server to access your cloud data store backend. So what you would do is the compute engine has a default service account associated with it, but you would have to add a role to that service account to get access to the backend database. So that's what happens. Like every time you launch a virtual machine, it has some service account role attached to it, and then you could either edit that role, that service account, the role attached to that service account directly, or you could just create a new service account and then change the service account out on that compute engine instance. So that's the idea. And if you look at this formulation, it's got your project. So my project ID is Handy Compass 212520. You'll see your project ID as part of that, and it specifies an email address. So it automatically generates an email address on your project ID, and this is for uniqueness. And then that's the service account. Okay. And you can see what you want to do when you set up the service account is give it least privileges, right? So this one allows you to view data store and view the logs and nothing else, right? And you'll see that this, maybe not in this CTF, this actually is over provisioned. It's like, do I really want someone to view the logs? I want someone to actually write the logs, but maybe I don't want this particular person to be able to view them. So that was the idea of that service account. Okay. Okay, a Google group. So here is our Google group for this class, actually. Google makes a group, an email list, so I don't have to like type in your emails manually when I send you an email. I don't really send you an email, but you can create your own group and then manage your group using standard Google tools, right? Versus if you had a different way of doing if you had a platform-specific way of doing the authentication, then you have group management software that is unknown, that you have to learn, right? So this is done all throughout the same group identity using Google Groups. And then the last one is this this Google Apps domain, and so you see pdx.edu. Everyone in that domain can read the compute images, which is what allows you to do the WFP image. Okay, are there questions about that identity on Google Cloud? All right. As we talked about before, there are roles, curated roles that Google specifies for these accounts. So owner, viewer, and editor. There's also roles attached to each one of the large resource umbrellas. So compute instance admin allows you to create, destroy, bring up, and bring down virtual machines on Compute Engine. So that's a curated role that gives you a bunch of permissions. And so we'll walk through that role in a second. And then they specify, so the policy is going to specify actions that are allowed on any of these resources. So all throughout the cloud platform, you have named resources that your policy will allow access to. Okay, so let's give you an example. Here's a Compute Engine instance admin role. And say I assigned this to a Google group. So say I opened up my Compute Engine to this class. I added that class group as a Compute Engine instance admin. And this is the project, so Handy Compass. So I could create this, I could attach this role to that identity. And then this role has, as part of it, a set of permissions. So I identified who. This role has a set of permissions, as we talked, and this is the policy. A policy is going to be attached to this role, and if you look at this policy, the policy has the actions, so any of these actions, and the green check marks mean they're allowed. If you had red X's, they'd be explicitly disallowed. So this says which actions are allowed on which resource. Okay, so that's how it works. Okay, are there questions about that before I just move on? All right. I talked about service accounts. So these are things that are attached to machines, or they're utilized by applications running on these machines. So here's an example where the service account is directly attached to a machine. So when you create a new virtual machine on Compute Engine, I don't know if any of you noticed it, but it gives you a default service account there, and it's like some compute engine default account. You can actually change that to a specific service account that you created that you have customized the permissions on. And that's what this thing is showing you. I wanted this, if you saw on the previous slide, I wanted a service account that only had view access on data store and view access on the logs. And so if I want that instead of the compute engine default, then I would just specify it when I create the virtual machine. So that's what that is. If I have a service account and I want an application to take on that service account and its roles, then what I will do is do something called, I'll basically create a service account key. So at any time, you can go to this service account and say, hey, I want you to generate a key for me, and I want that key to embody the roles associated with the service account. And that's what, if you go to IAM service accounts and you click on level SSH, you'll see there's this box that says create a key. Yes? If you create your own instance and you wipe out the default one and you put something else in there instead for that VM instance, you didn't delete the role. The role is just there. So if you actually go into your IAM service accounts, you'll see maybe like a dozen default roles. And these are roles that are automatically attached to things like virtual machines. But if you decide to create a virtual machine without the compute engine default role, it's still there. You'll have to add your own there. And you know what? I'll just show you that. It's nothing like actually seeing it in front of you. This is a different project I have. So you can see this is the default service account for the compute instances. Now you see how there's only two. So basically what happens when you enable an API or enable a service for your cloud project, that's when the default service account gets created. So for this particular project, I've only ever touched compute engine. So that's what that thing is showing you. So you can see it, compute engine default service account. And so when I create a new virtual machine, it will default to this, unless I give it something like that, which is the one above. Oh, that's an App Engine default service. I actually haven't created a custom one on this project. So yeah, App Engine is a platform as a service. So by default, App Engine, when you deploy an app in App Engine, it takes this role. And if your App Engine actually needs a bunch of like cloud data store stuff, and it's not included as that role, you have to go in here and attach that role to this service account in order for your App Engine thing to work. So. Yes, unless you actually explicitly go and delete it, which people have in my cloud class. And then I'm like, I don't know how to regenerate that. I think you have to like disable and re-enable the API, and then it will recreate the default service account. But people have actually gone in here and deleted the service account. That was, I don't think it will allow you to if it's attached to a resource or an identity, but like, yeah, probably don't want to delete the default service account unless you know that you have something else there. Yeah. It's per project. Yeah, so this is my TCTF. That's why there's very few. I haven't done much on this project, but on other projects, you would have a huge list based on all the services that you've enabled for that project. Oh, no, it's not. So yeah, so the question was, does this get created per VM instance? No, it just attaches this. So if you created 10 virtual machines, they would all have this. Yeah.
Each project is...
Yeah, and if each project has its own, so no, that isn't bound to mine. There must be some unique identifying thing with that, yeah. So if you created a second project, you would have a different set of service accounts. So yeah, and then you would have to figure out what, yeah, don't mix your service accounts between projects because that'll blow you up. In fact, this one doesn't even say. So here's the thing, like the service account, the identifier gives up your project name, right? So maybe they got rid of that because maybe you don't want someone to know your project ID. But my screenshot hasn't changed.
Yeah,
So like,
I don't think it's that way anymore. I'm looking at a couple of projects too.
okay. So yeah, so that previous thing that I had on the other slide, you can just delete that, pretend I didn't say it, where it said project ID, freaking changed it. All right, well, I knew what I signed up for, so. Okay, so these keys are basically shared secrets between you and Google. So your application has this key, and that's a secret between you and Google that will authenticate your application as that particular service account. Okay, so these keys, you can either do this to create a key, or there is a command line way in GCloud. You do GCloud IAM service account key create is like the command, and then you can do the same thing as clicking this button. The big thing with service account keys is that, yeah, you have to keep those things secure because they're basically allowing anybody to take on that role that you have associated with the service account. Okay, so these keys are stored in JSON files, and I should say okay, so I'll get to that. They're stored in JSON files, and if you peek into these JSON files, you'll see the type, the project ID, the private key ID, and we'll see that AWS has something similar called an access key ID, and then the actual private key itself. And so I deleted some of this here, but then this has your secret key, so it's using public key, private key cryptography. And then the name of the account that is associated with, and the client ID. The path to this file, if an application needs to use the service account to generate requests from itself, then what happens is there is this environment variable, Google Application Credentials environment variable, where the program can basically use this is a pointer to the file that contains the credential, and then the application will basically access the key there to perform the request as the service account. So that's one of the things that gets done. So this credential is supplied whenever the application is accessing cloud platform resources that are off of the machine. Okay, if you, in the CLI, if you have a service account key and you want to do some testing as the role associated with that key, you can do a gcloud auth, activate service account, and then point it to wherever that JSON file is stored in Cloud Shell. This is what you're going to do the very first thing in every Thunder CTF level. We're going to give you a credential, a service account credential in a JSON file, and you're going to take on that role, and then with that limited role, you're going to try and bust open the project and get the secret. So that's the whole set. This is why I'm giving this to you, because that's what's going on, right? Like we create a service account, we create a service account key, we give you the key, and then you're going to explore the cloud project using that role. Okay, and this is, in the command line, this is how you take on that role. Okay. The next thing I want to talk about are identity tokens, and this will also come into play in one of the CTF levels. If you can consider that one of the previous VMs where I attached this service account to the virtual machine, when the VM wants to actually access a cloud API, for example, you have a pointer to some kind of credential, perhaps it's a JSON file. Do you want to send that over HTTP to hidden API, is the question. And the answer is not really. So this is not recommended. Like you have a JSON file there, but you don't want to actually use that long-lived JSON file to do any sorts of signing of things long-term. Typically what is done is to do an ephemeral authentication. And so because this credential is meant to be long-lived and persistent, there is this notion of using an identity token, a shorter-lived credential that will expire much more quickly than the service account key. Because the service account key is generated kind of manually, right? Like you're actually saying, issue me a key. But like the requests, you don't want that key to be persistent because then if you get that thing compromised, it's a long-term compromise. But an identity token, if it's short-lived, then if that thing gets revealed, the time-limited nature of this token will allow that thing to expire quickly. So the way Google does the identity tokens is through standard OAuth 2. So again, they've opted for the streamline. So this is how you don't have to learn multiple different identity and authorization schemes. It's using all OAuth 2, which is just a web standard for identifying people through a third party. Okay. And the way you take a service account key and you get a token that will embody the key's identity for a short time to get a token is with this command, gcloud auth print identity token, and whatever account is associated with your CLI will get issued a OAuth 2 token. And then you use that OAuth 2 token to authenticate a web request. So this is something that one of your, like level 5 of the CTF does, where if you expose that identity token, for the lifetime of that identity token, you can take on that identity. And so for level 5, when you get your token, use it fast to finish the level. Don't get the token, go and get coffee and come back and expect your token to work. Yeah, get the token and then use it is the idea. Actually, we have it set up now. We have it set up now that it's all built into the same command. So actually, we changed it because people were having that issue last time we ran this thing. So I'm going to walk through an example of what you'll be doing in Thunder CTF with these tokens. So in one of the levels, you'll have a cloud function. This is a serverless function that's got an HTTP endpoint. And this HTTP endpoint requires authentication. So it's not just a website. It's basically requiring you to provide an OAuth token in order for you to get access to whatever's behind it. And say you're in the CLI, you're in Cloud Shell, and you want to be able to hit that endpoint using an authentication token. So the process would be, if you have the service account key that you want to take on the role for, and say that's stored in key.json, then what you would do is you would first activate this thing. So now I want to take on the service account role that's associated with that file. And then I'm going to get an identity token for that service account, and then I'm going to attach that in the standard OAuth way, which would be in this authorization bearer request header. And we talked about this a couple weeks ago, the bearer token. And then I can hit the endpoint. So here's my endpoint, super secret, and then in the header field, I can just do an authorization : bearer, and then this is the way of just taking the output of this command and then using it directly into the request. So actually, you won't be able to get a cup of coffee unless you make coffee fast. This token is going to be good for this particular level. Yeah, we had to change that because by the time people were cutting and pasting that token, I don't know what they were doing. I think the token's probably pretty good. It's like for 15 minutes or something. But now you don't have that problem anymore. Okay, the last thing I want to talk about is the metadata service. So how do we implement this in an application, right? Like I showed you how to do this in the CLI, but like every time I want to access an API, I'm not going to go to the command line and do this. The way tokens are issued on on a compute engine instance, for example, if you have a service account role and you want to get a token for that role to hit an API, the way that is done is through this thing called the metadata service. And every virtual machine has its own metadata service. And among other things, and this is the URI for it, metadata.google.internal, and it's only significant on the machine that you're currently on. And it'll point to your local metadata service. This is not some website that's centralized that Google runs. This is sort of like localhost on a specific port. You can think of this as. And this thing is it's the storehouse of all of the important things in your project. And so things like the project ID is in there. And you'll see, this will be part of your lab. The region is there. All of the service accounts that are sort of associated with this virtual machine. You can actually attach multiple service accounts to resources. And then any of the identity tokens. So the metadata service will go and will actually request and obtain identity tokens on behalf of the applications running on that virtual machine. And so it's done. This is basically taking the place of what we just showed you on the CLI. It's like, okay, I'm going to ask the metadata server to get me a token that I can then use in my application to make that request. There's a better figure of this when we get to the AWS stuff, but that's effectively what the metadata service is doing, yeah.
So that the URL there, is it specific to the VMIP?
Yeah, in fact, it's sitting there underneath in the hypervisor. At least on AWS, it's sitting there in the hypervisor that's running your virtual machine. And so, but the information you'll get from that is specific to the machine that you issue this request on. So that there's like one VM's metadata service isn't going to be able to see another VM's metadata service. Yeah. Okay, so because of all of this stuff is there, these two things, this is the thing that's often a target for attack because it's got all the essentials of your project. Okay, so with that, I think you have all of the knowledge you need to understand the levels in the CTF. So the labs, this Thunder CTF, this is a CTF that we created to try and help students learn about cloud platform and cloud platform security. If you haven't looked at it already, you go to this URI, which I'll show you here. And it gives you specific instructions on how to set it up. You can skip the read the first paragraph. It's basically, there's a secret in every level that you're trying to get. The secret is what I want. Like when you come across that secret, just take a screenshot of that with your cloud project ID on it, because I think that's got your name, and then call it good. So 6 screenshots is all we're looking for on this. You already have an account. You can actually use your class project account because there's barely anything running on it. So you don't have to create a new project for this CTF. I know it says to, but like they weren't expecting, well, we wanted these instructions to work for everybody. And I know it'll work for you. You're using the cloud project that you currently have. So you can skip the first couple of steps. And then this is the setup. So you'll have to run this. And what you're doing is you're creating a Python virtual environment, downloading the code, installing all of the Google packages that we need to deploy levels, and then this is the last piece, activating the project on your project ID. Your project ID is whatever your Cloud Shell says it is. So you basically want this. So in my cloud project, this is TCTF-01. Sometimes when you get into Cloud Shell, and you don't do anything too quickly, it'll automatically generate your cloud project and set that thing in yellow. If not, you basically have to run the command that Thunder CTF asks you to do this gcloud. So this one. So this particular student who developed this, he liked working locally using VS Code and Google Cloud locally, and then you have to type this in manually if you're trying to run these things on your laptop. But Cloud Shell will automatically set this for you. And then all you need to do is this one to activate it for your account. Because what you want is all of the Google Cloud commands to be pointed at the project that's hosting your CTF. So that's what that is. Okay. So I'll just show you a demo of the very first level. This is sort of the hello world of the CTF, A1 Open Bucket. You'll click on this level. And what you'll see is the setup. So this is, you activate your environment that you had here, and then the way to start a level, Python 3 thunder.py create, and then that's the level. At the very end of this level, there's a Python 3 thunder.py destroy, and it doesn't take any parameters. It'll just destroy whatever level you've currently deployed. Typically only one level at a time is allowed. So you start a level, you destroy a level. You start a level, you destroy a level. That's the model of this CTF. Let's see. So here I am in Cloud Shell. If I go to here, there's an environment. I've already done the commands in the first thing. And then I'll go into Thunder CTF. I'll create A1 Open Bucket, and it'll go and it'll create those resources for me. And then the level, you can start the level in the UI. So you go to next, and it'll say, oh wait, no, it gives you the goals in the previous one. The secret for this level is in a cloud storage bucket. You're given a bucket name, and then it's written in start/a1openbucket.txt. So the instructions to begin this. And then what you'll see, the next button, there is a sequence of hints. So the idea is that if you need help, there's a hint system for you. If you don't need help, don't use the hint system. So this adapts to the level of support that you need. And so if you use all the hints, it's like a walkthrough is the idea. Okay, so then if you cat the message, it's basically telling you it's in a storage bucket called this. So then you can do a gsutil ls of the gs://a1 bucket. And then you can see the file there. You can use gsutil to copy the file over. You can cat the file and then take a screenshot, and then you're done. So that's the first level. Okay, they're all similar. So the later levels actually have you activate a service account. That one didn't, but that's the idea. Are there questions about that? Because that's all I'm going to cover. The goal for the class would be to get through this by Monday, and then I'll just switch right on over to AWS after that. Okay, any questions? And I'm here to help for the rest of the class to get you through levels. Yeah.
The lab right, you want just that one screenshot, but also do you want what is the thing that we're...
No, I don't want that anymore. Yeah, that's just too much. There's too many things that are going on here. Just finish it and yeah, 6 screenshots. I'll call it good. I think, yeah, you've gotten enough practice doing the other stuff. Did you have a question, Ellie?
Oh,
that was your question? Okay, yeah. I posted it on the channel, but I'm making the announcement now. Yeah, all I care about is the final 6 screenshots, and I let Jeff know, so he knows how to do that. Okay, so then, yes. Access token. Where do you see the access token? I think they're the same. What do you mean by access token? Like, in what context have you seen access token? Okay, is it in a JSON? Oh, wait, is it a OAuth token? There are many kinds of tokens. OAuth, there's JWT, there's different ways of doing token systems. I think people are standardizing on OAuth 2 and JWT as ways, because JWT, OAuth is more identity validation. JWT is a kind of OAuth token that does attestation of authorization levels. Like if I want to say, not only is this person who he or she says they are, but they also have read and write access to this bucket. Like if I want to do some attestation, there's this thing called SAML, which is a markup language for saying not only, these are authorization statements that I also want to authenticate to the third party. And in fact, Portland State uses SAML. When you go on their single sign-on, they actually use that to do the authentication and authorization. So maybe the access token you're thinking of is different, but I think the identity tokens you're going to use in this class are basically the OAuth, the bearer tokens. But you would have to show me, and then I would be able to tell you what those things are. Okay, so I'll let you get to work.